We're going to build a fully functional cross-platform Facebook Messenger clone using React Native and Nest.js. You only need some basic skills with React and Nest.js, as we're going to learn all about microservices with Nest.js, RabbitMQ, React Native, Docker, Postgres, Redis. So if that sounds exciting, let's jump straight into the system design. For anyone that hasn't worked with React or Nest.js, or they want to dive much deeper into building a practical project to get comfortable with the technologies before diving into the Facebook Messenger clone, I'd suggest that you check out my YouTube channel. I've got a 30-hour LinkedIn clone series, and I've also have a 12-hour Amazon e-commerce shop series on my YouTube channel. And also, in this video, we're going to be exploring microservices with RabbitMQ. If you've never seen microservices before, I've got a quick 15-minute tutorial on my YouTube channel, so make sure you check that out. It's all about microservices, what they are, the message brokers, and also the different types of transports and how to select the right one. It's a great video, even if you do know about microservices, as it provides great context for what we'll be building in this Facebook Messenger clone series. So make sure you check those out, and without further ado, let's get started on the system design.
So we'll start with our client. The client is where we're making the request from. So this is just going to be our mobile device in the case of the Facebook Messenger clone on our mobile device. And this is going to make a request to an API gateway. So I'm going to have this service here. This is its own server. And the API gateway is responsible for handling the request and forwarding them to the right service. So if we think about our Facebook Messenger clone, the very first thing the person's wanting to do is they want to be able to log on. So they're going to want to actually sign up and then log on. And to do that, we want to have an auth service that handles that. And data relating to users is often best done in a relational database. So we're going to actually connect to a relational database here for that sort of data. And this will be the Postgres database. So I'll put PG here for Postgres. So what other things would we want in our Facebook Messenger application? So we're now able to sign in and register an account and log out and all those sort of user-related functionalities. Another thing we'd want to do is we want to be able to chat. So that's a big service in our Facebook Messenger clone. But before we can chat, one thing we might want to do is we might want to see which of our friends are online or not. So we can have another service here. So I'm going to have a service here, and this is going to be called Presence. And that's basically the green light or the green circle you see on your friends list to see who are online and who is offline. Because often you'll go to that page and you'll be able to see, oh, well, if someone's online, you're more likely to send them a message. And depending on if they're online or offline, it may, we'll have different interactions or different ways of handling the way the message is received. And another service that we might have is we might also want to be able to call. So I'll put that over here. And that's basically video calls or audio calls that you might have. And with chat, the thing about chat is you actually have, there's huge volumes of messages that get received and need to be dealt with. And there's often in a chat application, imagine usually one user sends a message, another user replies to a message. The user might send a couple of messages and then the user might receive a couple of messages. But all in all, it's roughly like a 1-to-1 sort of read to write ratio there. And because we've got such large volumes of messages that we need to access them quickly for our whole application to run smoothly, So something that would be good to handle that in terms of data storage would be an in-memory data caching or key value storage. So I think a good choice here will be Redis. So I'm just going to put this here. So Redis, we can use this actually for many purposes. It's not to be confused with the Redis transport layer, which we discussed in the previous video. But Redis, it actually started off as an in-memory caching to be able to access things very, very fastly. But you can actually use it as a primary database, and we're going to use it because it's super lightweight, it's super performant, and because we're dealing with such large volumes of these chat messages, it's going to allow us to, have that quick access to that.
So you may be wondering how are all of our services going to communicate to one another? And we're going to use RabbitMQ. So RabbitMQ, as mentioned in the previous video, is the most popular message broker. We're going to use it mainly for its reliability, but it also deals with complex routing, and it's highly available. So let's take a look at the RabbitMQ and how it works. So basically, we're going to have some sort of service. So let's say we have a service A here, and we call A the producer. So a producer is the person that creates the message that's going to get forwarded. And then likewise, we're going to have a consumer. So on the other end of this, we're going to have some sort of service here. We'll call it B. And this is the consumer. So as we talked about in the message broker video, if A is going to receive lots and lots of requests, it needs to be able to handle those. And if it receives a request and is still processing the request, it's going to, clog up the server. And that means other requests to A aren't going to be handled nicely. And on the other side of things, if B has lots of requests that it needs to handle based on A, they'll slow down things. So the solution to this is actually to create another server. And I'm just going to put this red box around everything here, just to indicate that this is essentially what RabbitMQ is. This is where the message broker side of things come into play. So the way RabbitMQ works is the producer, it creates some sort of message. It gets a request and it needs to be able to handle that request. So what it does is it actually moves that into what's known as an exchange. So this is an exchange. And the exchange is responsible for taking the request and sending it to one or more queues, depending on the particular route or whatever it's trying to solve. So we can actually, this exchange, it can forward to various different message brokers. And these are going to be the queues here. So this is a queue data structure. So basically, what it looks like here is A, it's receiving a request and it wants to keep receiving more and more requests. So it offloads the particular request. It sends it firstly to the exchange. The exchange is then responsible for, it puts it at the beginning of the queue. So in this case, there are no tasks in the queue. So it's going to send it to the front of the queue. And it could do that for multiple ones if we're talking to multiple services, for instance. And then B, the consumer, it's looking at these queues and it's basically when it's free, when it's not dealing with any other tasks, it can take something off the queue here and it can go ahead and it can process that. So what it means is A is able to get more and more requests. It can offload those into the exchange and they sit in the queue. And B just deals with one of them at a time. Now, it is possible that we have more than one consumer here. So I'll just go ahead and highlight that by putting another service in there. But as you can see, the RabbitMQ, it's basically extending on the message broker video that we've seen in the previous video. And we're now able to handle requests. How does RabbitMQ work? Well, let's say we have a server and it's receiving lots and lots of requests. We don't want that server to slow down. So we want that server to continually receive requests. So we can actually offload some of the tasks into a queue. So this is where RabbitMQ comes in handy. The producer, it creates the message, it offloads it to an exchange. The exchange is responsible for forwarding that to a queue or more than one queue if it connects to multiple services. The exchange, it passes it to the start of the queue, and then the consumer, it's waiting for a message. When it's not dealing with any other task, it can pop something off the front of the queue and it can handle that process. So where RabbitMQ solves an issue is it takes the load off the producer A. It it separates where all those processes are happening, and it deals with them one at a time through the queue data structure. And then B, it also is only dealing with one process at a time, which means A and B, they're no longer receiving high workloads. And then also the RabbitMQ, this is sitting in its own server to handle all of that.
Another technical point about RabbitMQ is that when the consumer receives a message from the queue, it's called an acknowledgement, and you may see this in the code as an AX, and this basically allows us to have that reliability there, because we can actually acknowledge that we have received a message from B, which allows us to remove it from the queue here, but it also allows us to process it over here with certainty that it's actually received the message. And the same isn't true in regular TCP communication. So we can see the benefit RabbitMQ has here. So now that we've explored RabbitMQ and the very high level overview of the system design of the Facebook Messenger architecture, let's go ahead and dive into the code and actually start to connect our first microservice up in NestJS using RabbitMQ.
Let's go ahead and get started building our Facebook Messenger clone. So the first thing we want to do is we want to set up the backend, and we want to set up the NestJS microservice. So we're going to see how to set up a microservice in NestJS, and we're going to use RabbitMQ as the particular transport. So of course we're going to need to have Nest installed. So go ahead and install the CLI there. And you're also going to want to use Docker, because Docker is the easiest way to get the RabbitMQ service up and running. So go ahead and install those for your particular operating system. And then we're going to jump into the code here. And we're just going to open up the terminal and just check that you got Nest installed by doing nest-v, just check you got the right version there. And we're going to run nest new API. So what we're doing here is, and we'll just use npm to scaffold it. What we're doing here is we're creating the base project, the API gateway. And what we're building in this video is we're building the connection between the API gateway and also the particular service. And we're going to use the beginnings of the auth service. So we're going to see how we can set up the microservice and RabbitMQ and have them communicate with one another using that mentions transport there. So let's go ahead and just let this load. Okay, so now that's loaded, let's go ahead and CD into our API. And if we look at this folder here, it's just the typical NestJS API. So we should be familiar with how to make a NestJS, or the NestJS boilerplate. So we should be able to be familiar with how to make a NestJS API. And if you're not already, please see my LinkedIn clone series or my Amazon clone series to get a good idea. because this is going to be more of an advanced project that builds up on at least the fundamentals of Nest.js. So we can see that we've built this, we've got all the boilerplate for our Nest.js application. So what we want to do is we actually want to use the Nest CLI, and there's actually a command, nest generate app, and we're going to generate the auth app. And before I run that, let's just take a look at this Nest CLI file, and we can see that we've got this source root here. Source root is source, and there's not really that much configuration going on here. But let's go ahead and run nest generate app auth. And if we just minimize this terminal for a second, we can see that it's added a whole bunch of stuff into our Nest CLI. So the first thing, or one of the important things to note, is that the root is the apps API. So it's generated this apps folder, and then it's generated the API folder in there because our base project was the API. So that's going to be by default the root. And we can see that, you know, it has all of the entry points and all that as you would expect. But you can see that we've actually got two things going on here. We've got the API, and then we've also got the auth, and these are applications. And this is what's known as a mono repo. So we can see here that we've got the mono repo to true. And what this allows us to do is it allows us to share any of our common code. So a way to do that is we can actually generate a library. So we can run nest generate, or G for short, library, and I'm going to call this shared. And this is just setting up a shared library. Let's just go ahead and use app as the default here. I'll go ahead and click enter here. And we see that it's created this libs folder. So if we open up the libs folder, and we see that we've got the shared folder in here. Now by default, it's just got this shared module, shared service, but we can add in there. So for example, we might have multiple different apps, but we need authentication or authentication guard on multiple different API endpoints or service endpoints. So, you know, that's one way we can share that functionality. The other benefit of having this mono repo is that all of our packages that we install at the root level will be shared in our apps. And that's really good because when we're using microservices, we have quite a lot that we do share. So for example, let's go ahead and install a few. So we're going to want the NestJS config service because we're going to reference some environment variables to set up our server. So we're also going to want to get the microservices dependency. And if we look at the documentation on NestJS, we can see that we also want to go ahead and get this RMQ lib and RMQ connection manager for using RabbitMQ in NestJS. So let's go ahead and get those, and we can just install those. We'll just wait for those to install, and then we should see in the package.json here, when it installs, we should get these extra dependencies here. So we see we've got the config microservices and these two here. So we can go ahead and close that. So let's just go ahead and close our terminal up. And let's just start to connect. Well, actually, before we work on the Nest.js specific stuff, let's get our RabbitMQ server up and running. So in the root of the API folder here, we're going to want to use Docker, and we're going to want to create a Docker Compose file. So let's go ahead and create that, Docker compose.yaml. And there's no expectation that you know Docker here. So let's just go ahead and run through what Docker is. Docker is a way to basically create containers. And what a container is it's basically a its own particular bit of software that runs, which manages all of the environmental stuff that you need. And the benefit of using it is that we're able to use it on any machine and have the same configuration. So I didn't want to go too much into the theory of Docker. I wanted to have a more practical, practical approach by learning by doing. So basically, what we're doing is we're creating a RabbitMQ server. So that's different to this servers here. And if you're familiar with the monolithic structure or architecture, there's just one endpoint for the. Oh, sorry, there's more than one endpoint. Unless you're on GraphQL, but there's one server, a monolithic server. Here we actually got multiple servers. So we've got the API gateway, that's its own server. We've got the auth service, which is its own server. And every one of these services is going to be its own server. So, and in addition, RabbitMQ is the transport, and it's also on its own server, as we see in the video. Before this video, in the videos before this video came on. So let's go ahead and check out how we can write it. So the first thing we have here is, and I should probably mention that I've got these Docker extensions here that helps you write the Docker file. So you can just go ahead and search Docker and extensions and get that first one there. It comes bundled with a bunch from Microsoft there. So that's pretty handy. But basically, sorry, we don't want version. Version is just like the latest version of Docker Compose, and the latest version just happens to be 3. You can always just go to the Docker Compose information on the Docker website to get the latest. It doesn't change too often, as you can see that we're only on version 3. But it's always good to check if you're not sure. And then in Docker Compose files, we can actually have this services key here. And one thing to note is indentation is important in Docker, so make sure everything's lined up as you see here. So version and services, they're on the same layer, and then you can either press tab or you can have 2 spaces. I got my tab set to 2 spaces, so I could press either. But the services are basically each independent server that we're spitting up, which is in its own container. So we want to get the RabbitMQ service going to start off with. So with Docker, we have this thing called an image. And an image is basically it's sort of like the blueprint, and it has all the complexity done for us. So on Docker, if you go to Docker Hub, you can search for pretty much anything you want: a Postgres database, RabbitMQ, Node, whatever it is you're looking for. And there's probably already an image created for you. So you just want to go ahead and see whatever it's called. So this is just called RabbitMQ. But we also want to have a graphical user interface for this. So there's also another one called RabbitMQ, and the specific version of the RabbitMQ is 3-management. So we can go ahead and search for this here. If we just go to Docker Hub and just type in RabbitMQ, we can see the official image here. And then, you can sort of look at all the different versions. For example, you can go into here, click on version 3.9 management. And there's a whole bunch of different information here. You'll see that it has specific port numbers and all of these sorts of things. So if you need to get into any of the lower level details, you can definitely come here and check them all out. But fortunately, I've done this ahead of time. So we can just simply reference that image there, and that is all we really need to do to have that. But by default, the container name takes the image name. So I'm just going to not want that 3 dash management there. So I'm just going to call the container name RabbitMQ. And likewise, I'm going to have the host name of RabbitMQ. That's just, they're not too important, these two here, or the one above it at least, because that's just a naming of the particular microservice. It just helps simplify things when you got a whole bunch of services running, just to easily identify which one's which. But something that is important is the volumes. And the way we have volumes, we specify by having a, let's see, a dash here like this. And a volume basically is where the data is going to be saved. So basically you have named volumes and unnamed volumes. So an unnamed volume is basically something that we will go on the server, in the Docker container. So the thing about Docker is it's sort of like Linux. If you're familiar with Linux, for example, where you have the operating system, and then you have your folders, and then you have all of the necessary software that you need on that operating system, and then that's what allows the actual image to be able to run on that particular container. So yeah, the image sort of is like a layer higher than that. So basically what it means is, what we can say here is, it's sort of like having a virtual machine, let's say. So like when this gets created, you can sort of imagine that you have like another machine, and that has its own folder structure and everything like that. And you can actually sort of access the folders in that virtual machine like thing. So basically on the Docker, or in the Docker container, there's a var library, and this is actually the recommended way to do it. If you look at Docker Hub, if you look at the details on Docker Hub, so I'm not just making this up. This is just following the documentation basically. So that means, like, because you can imagine that you have like a database, you don't want to lose the information on your database. The volume allows you that information to be sort of bound to the container. You can also make it bound to this local files and stuff like that. But right now we'll just focus on this here. So we can also have some ports here. And by default, the Docker port is 5672. And the reason we have this in a string is because we're actually going to map it. So we're going to map it to 5672. So you might think, why do we need to do this? So basically you got to imagine that there's two different machines. There's our machine, and when you normally, have NestJS on port 3000 or React on port 3000, you can just run the application and go to the port. But you got to remember that this Docker file, or this container is going to be running in its own sort of machine, let's say. Like technically it's running on this machine, but it's treated as if it's going to be on another machine. Similar to like when you deploy it, it's not actually going to be on your machine, it's going to be on another machine. So basically we want to be able to access it on our host machine. So our host machine is going to be 5672, and then we can map it to the machine, the port that's in Docker. So that allows it to communicate between the two. So the other thing we want to do, or the other port we want to have here is 15672. And again, this is just from the documentation. And why we have two ports is, well, we want one for the actual RabbitMQ server, but we also want to have another graphical user interface, which comes with this 3-management one. So we should be able to, access that on a different port. And the final thing we want to have here is we want to have some environment variables, because you can't just log into these services. Well, you can if you don't have a password, but that would be really insecure. You need a way to actually log into all of these different tools like databases and these management consoles and all these sorts of things. So you can have something here, which is an env file. And this is just going to point towards a .env file, which we're yet to create. So let's just go ahead and create this env file. So the env file is going to sit in the root here. And basically, we're just going to have a whole bunch of variables here. And these variables allow us to access them both from our Nest application and also in our RabbitMQ application. Because right now, I'm just going to have this service here, just mainly because it's the easiest way to get the RabbitMQ server up and running. But we also want to connect to it with NestJS. And just for this video here, while we're learning about microservices, I'm going to have those NestJS services just running locally. I will move them into the Docker Compose file in the next video. But in this video, I really want to just introduce microservices and just how they can connect to one another. So let's go ahead and come up with some environment variables. And these variable names, they're also in the Docker Hub RabbitMQ documentation. At least some of them are, like RabbitMQ _default_user. And I'm just going to call this user. And then I'm going to have another one here for the pass. For some reason, I don't like the word password. They choose pass. And then, so these are the variables that are defined. I don't know why that happened. These are the variables that are defined in the documentation. So I'm just going to go ahead and sort of copy this same syntax here, where it's the RabbitMQ _ whatever it is, for my particular variables here. So I'm going to have a RabbitMQ user. So we've got the default user, but then we also just got the RabbitMQ user. And these values can be whatever you want them to be. You just got to remember what they are. So I'm just going to make them simple. So I'm going to have the RabbitMQ user, which is user, RabbitMQ pass, which is password. Let's just copy this down 2 more times. We're going to have the RabbitMQ host, which is localhost 5672. And we're also going to have a queue. So we're going to have the queue. So right now we're going to, so we've got our API gateway, and then we're going to go to our auth service. We want to connect that. So there's going to be an auth queue in between those two. So I'm just going to have a RabbitMQ auth queue. And I'm just going to call this auth _queue. And these environment variables that we've defined in the root, they're going to be available everywhere in our application if we use the NestJS config service and make use of them. So now we've got that, we should be able to run our Docker Compose file. So let's go ahead and just open up the command line. and we can just simply run docker-compose up. And actually, before I do that, I might just go ahead and connect all of the NestJS stuff. Actually, let's just see if that works, just to make sure. So we know that we've got the management in 15.6.7.2. So let's just wait a second for this to load. And actually, this might take a second to load the first time, because it's got to go through all the different layers and get RabbitMQ and all of that sort of stuff. But basically, when that loads, we can go to localhost 15. Oh, there we go. We got it loaded already. And then we can see that we're in the management dashboard. And then if we want to log in, we can log in, what was it, username and password, I believe. We can go ahead and we can log in. Username, password. Okay, I'm not sure why that's failed. Oh, it's just user. Let's come back here. User, password. And then we can see we're in here. So we haven't actually set this up yet, but we've got this queue here. And when we set it up, we're going to see our auth queue, and we can actually see the communication between the services. And so we've got these exchanges here and these queues here, which we'll look into when we set it up. So let's go back to our code, and we can close this up. We can close this up. I might just Control C this to kill that. So let's just run docker compose down just to make sure. Okay. So now what we want to do is we want to actually let our API gateway communicate with a microservice. So if we go, the first things first is if we go into the API source folder here, and we go into the main here, we see that we're listening on port 3000, and that is what we want, because the API gateway, that's receiving the request, the HTTP request from the client. So we want to make a port publicly available, but we'll see in a moment with the microservices how this changes. So let's go to the app module. Now in the app module, this is where we can start to define our microservices. So first things first, we're going to need access to those environment variables that we created. So let's just actually reopen that environment variable so we can easily copy and paste the names of them. But we can actually go ahead and use the config module here, and we can use for root to access it globally throughout our application. And we can just go ahead and set is global to true. And we can access the environment file path. Now that we're in a mono repo, the relative files are from the base. So we can just say .env, the base here. So we can access those environment variables here. So we see that we've got the typical app control, app service. We don't really care about the app service. Let's just leave it there for now, but let's just because we want one service that will come back to changing. But basically what we want to do is we want to provide, our microservice with the ability to communicate here. So basically, we need to provide all of the environment variables to our config, to the auth service. So we haven't actually created the auth service yet. Perhaps it might make more sense if we go to the actual app itself. So let's actually, before we come here, let's actually go to the actual microservice. So we've got this API folder here. We've also got this auth folder here. And if we open up the main file here, we see that this is also listening to port 3000. Now, we don't want to do this for our auth service. It is possible to listen to the ports and also have the microservice communication. That's called hybrid microservice, and we've seen that in the previous video. But we want this to be a microservice, and then we want to be able to call this microservice and communicate it from the API gateway. So what we want to do here is we still want to use Nest Factory to create the auth module, but we want to just go ahead and delete this line here. And what we want to do is we want to access our config service. So let's just say config service by taking hold of the app, and we can go ahead and get the config service. So we should be able to import that from NestJS here, and we can save that. So basically what I want to do here is I want to get all of the variables from the config service. So that's these variables here. So for example, RabbitMQ user, we want to get hold of that. So let's have a variable here. We'll call it user, and we'll use capital letters to signify that it's not going to change. So we can use that config service here, and we can just go ahead and get the RabbitMQ user, and then we're going to do the same thing for the password, for the RabbitMQ host, and for the RabbitMQ auth queue. And then of course we can rename these. Password, host, queue. And then we can just save that to get prettier. So what we can do, rather than connecting to the port, we can call app, and there's actually a method on it called connect microservice. And this is going to be of the type microservice options. It's going to, have that generic type that it can call with the microservice options here. And this will give us some type safety for our, not type safety, IntelliSense for our object that we want to create. So to specify the particular transport that we want our microservice to use, we can just go ahead and use this enum here. So we can use the transport enum, and let's go ahead and grab that in from NestJS Microservices. And then we can see that there's various different types here. We want the RabbitMQ one, because our app's going to talk to one another using the RabbitMQ transport. So then we want to have some options here. And this is where we specify the URLs, for example. So we just have an array here. I'm just going to use backticks here. And I'm going to access the URL AMQP, which is what we're going to get from our RabbitMQ connection. And then they'll allow us to use these template literals here to get the user, to get the password, and we can have the at $ host here. So if you're looking at this, it looks very familiar to how you connect to, say, a Mongo database or a Postgres database or something like that, because it's essentially the same thing. You have a bunch of details, user, password, host, that you're trying to connect to. Another thing that I mentioned earlier is that, and this might have been in the previous video, but a producer produces a message, a consumer consumes the message, and when the consumer takes the message from the message broker, it can acknowledge it, and that's known as an ACK. So we can have something here that says no ACK, because by default RabbitMQ will auto acknowledge things. We want to set this to false because we want to manually acknowledge our requests, and that sort of helps ensure that they don't get lost or anything like that. So the next option here we want to have is a queue, which we can just set to our queue, and then we can have some corresponding queue options here. I'm going to have durable here. So durable, basically what that allows us to do is the message broker won't be lost, or the data associated with the message broker won't be lost between restarts. We can go ahead and we can save that. And then finally, after all of that, we can come here and we can say start all microservices. So what we've done in our auth microservice, we've sort of, in the main TS file, we've just sort of said that it is a microservice. It's using the RabbitMQ transport. We're connecting to our, our RabbitMQ server, and it's starting that. And that means if we configure our API gateway or any other service, we should be able to communicate to this microservice. So basically, let's just take a quick look at the auth module. So if we have a look at the auth module here, we actually might want to copy this auth module here, because we're going to want to have those, we want the config module to be imported here. Let's go ahead and get that in there. The rest of that can stay pretty much the same. But now let's have a look at our auth controller. So we can see here something we want to do is we want to be able to communicate to this, to here with the transport. So with regular API calls, you see things like, these annotations, get the hello, for example. With transports, with microservices, we're going to have this message pattern annotation. And the message pattern, what we can do here is we can actually have some CMD. I was getting React IntelliSense for some reason. So we can actually call this something. So let's say we want to get a user, for example. We'll just say we get -user. So we're going to, there needs to be a way for the API gateway to talk to this particular microservice. So we need some sort of way to communicate, and having this command get -user, if we have that in the API gateway, similar to if you have a service or if you have a controller and you have a particular endpoint that you're using, so this could be /user, for example, the API request will make it into the controller, and then it will look for that particular route, and if the route matches, then it will call the corresponding method. Similarly, the API gateway, it's going to detect a particular command or string or something like that it can hook onto and then call if it finds the particular match. So we can have a function here, and I'm just going to call this, well, it doesn't really matter what I call it, but let's just call it get user, let's say. And basically what we need to do is we need to access the context, and this comes from RabbitMQ. So we can access the context by having this context come in from the NestJS Microservices package, which I don't know why that didn't import. Let's just grab it in. And basically we can go ahead and set the variable context to RabbitMQ context. So we can bring that in as well. Let's get that. Okay, let's get that. So basically we can just go ahead and we can get the channel. So basically on the context object that RabbitMQ provides us, we can just go ahead and call this function here, get channel ref, and on that particular functionality. So I mean, this is obviously built into the library. You don't have to know all the details, but basically the channel ref, it allows us to get the particular message from the context. So we might be able to just get the message right. So if we go to context, get message, that allows us to actually, you know, check that we've you know, that it's the right command that we're looking for here. And what we can do at this stage, because the API gateway, if you recall, has created the message, it's gone through RabbitMQ, so we need to get some of the context from RabbitMQ to be able to get our message from the channel. And then at this stage, we've sort of consumed the message, so we can acknowledge that we've consumed it by saying channel.ack and then passing in the message that we've got from the context there. And then finally, we can just go ahead and we can just return. So I'm just going to return some sort of user here and user here. So that's what the microservice looks like. But how do we connect that to the API gateway? So I think to be able to address that, we need to come back to the module. And we can actually copy some things potentially, like these here. So we come to the app module, we've got our config module injected here, or imported here, I should say. And then we have this provider, we've got the app service, but then we want to actually provide an auth service. So this is the way we can communicate to our actual microservice. So let's go here and we can say provide auth service. And basically we're going to use this auth service, we're going to inject it into the app controller, and we're going to see exactly how this works and sends to the thing, to the microservice. So we have, because basically what's happening is we've got the API gateway. It's not aware of the functionality in the auth stuff. So we want to be able to consume that from the gateway and then forward the request to the appropriate service. So we do want the API gateway to be aware of the auth service and handle the auth service. So we can just actually come here and we can say we want use factory here. Actually, we don't want that. But what we do want is to be able to say that the use factory, and we're using factory because we want to pass in the config service. So we can just go ahead and pass in the config service here, which is of type config service. And then we want to go ahead and we want to copy and paste all those variables we had here. And then what we can do is we can return a client proxy factory. And we can go ahead and we can firstly import that. So that's coming from the microservices package. And that allows us to create. So we still need to have the transport here. So we can have our transport, which is going to be of the transport type or enum. And it's coming from here. And we're using RabbitMQ. So we can actually copy this once again from here. Actually, we can copy pretty much all of this here. So I'm just going to copy all of these options here. And we can see that we're connecting to the same URL. Got the queue here. We can get rid of that because it's on the other side that we're acknowledging it. True. Okay, so basically what we've done is we've got the API gateway set up with microservices or able to connect it. So the final and missing piece that we need to complete this is to come to our app controller and start to inject that service that we just created and able to communicate that. So what we want to do is we want to, well, the same way we inject services here, we want to go ahead and inject the auth service. So that name is coming from this custom provider that we have here. And the auth service, this should be private because we only want to access it from within the controller. So I'm going to have the auth service, and this is going to be a client proxy. And then we're going to need to import that. Let's go ahead and save that. For some reason my imports aren't working smoothly. We can go ahead and get rid of the app service here. We can go ahead and delete this here. And we should probably do this in the other service as well, but we'll clean that up later. You can get rid of this get here. And now we just need to make use of this. So let's go ahead and have a get request here. So let's just go ahead and get. Let's actually add that back in. Basically, we want to have a method. We'll call it getUser here. And this is going to return this.auth service. And then it's going to send. And then it's going to send the CMD get user. So usually you send like some data. We just need to have another object in here like that. So let's go ahead and bring our Docker Compose up. And in another terminal here, I want to firstly cd into API ls. Okay, so I want to run npm run start dev, and you should always start your microservices first. So let's run this command here to start the auth microservice. And let's go ahead and, okay, I'm not sure if that errored or not. It says no errors. Undefined. Not sure, might have an error. And then we want to cd in our API and run npm run start dev API. Okay, so it is looking like we're getting some errors here. So this configuration for root, it needs to be a .env file here. So let's also check that is in the, let's see here. Let's just check our files here. Okay, so let's go ahead and try and run that again. Because previously we're getting failed to connect. Okay, this looks better, lots of green. So let's try and connect our API gateway. Okay, there might be a similar sort of thing going on here. So we can see also in our app module here, we want to have .env here. And then let's try and start our API gateway here. So you can see in RabbitMQ, we've got this auth queue from that auth service, but one thing we forgot to do is we need to actually inject the config service. So we're using it here, but we also need to come on this same layer here, and we just need to inject that. I can do that by calling inject and have an array of all the injectables and calling that service. So now, if we run our API here, we can see that it's built. So that's a good sign. We can refresh here, come to localhost 3000, And this is happening really quickly. If we had that no acting off, it wouldn't have processed this and taken off the queue. So we can actually see we've got this user here, and we've done that with microservices with RabbitMQ in NestJS. So let's just have a quick recap of what we've done here. Well, we've set up let's just start from a closed folder. So we've created the Docker Compose file. We're going to add in those 2 NestJS services into the Docker Compose file in the next video. In the next video, we're also going to set up some authentication and the auth guards and protect different things. So we're going to go dive deeper into that. But here we see we've used Docker Compose to get the RabbitMQ server up and running. We've got some environment variables here. Everything in this root level here, including all the dependencies, they're available in our apps. We also have this libs folder that we haven't used just yet, but we're going to use that in the next video for our shared code. And then the key difference is we've got apps here. So we've got our API gateway here. The API gateway, this is accessible by exposing a port. So through HTTP requests from the client to the server. Then in the app module here, we've actually connected the auth service with the environment variables here. So we've created a client proxy using the RabbitMQ protocol. So that means if we ever, if this HTTP request gets called, it can offload that to the auth service. And the auth service, because it's connected with RabbitMQ, it transports that to the appropriate microservice, and then it does that by hooking onto this get user here. So if we just take a quick look at the API, at the auth service, the difference between the main files are that we don't expose a port here. We connect using this microservices approach, and we connect with all those variables here. Then we can come into the auth module, give it the config that it needs. And then we can come to the auth controller. And the auth controller, it has this @message pattern decorator. So the RabbitMQ transport handles that, and then it looks for this particular command here. And then it's able to, through the message brokers, through the context there, it's able to hook onto the particular message, and we're able to acknowledge that. And then we can give back the message user. So we've done a great job. We've learned all about microservices in NestJS. It's the same sort of thing for most of the other microservices. So we've connected an API gateway to an auth service. In the next video, we're going to continue to build out the Docker file for the services, for the NestJS services, and we're going to build out some authentication. So make sure you subscribe to my YouTube channel and stay tuned for that next video. Thanks so much for watching. Cheers.